interesting lecture. The lecture is from CBS, sales manager, sales and marketing manager, Mr. Na'man.
He is the GM.
He is the GM. Okay, sorry, he is the GM, Mr. Na'man. He will present us the topic of fire and smoke in buildings. Engineer Tariq, he will give a small bio for Mr. Na'man. Engineer Tariq Samir, he is the sales manager, and he will give you a small introduction about Mr. Na'man. Please.
احنا شركة مصرية اسمها بدر عصفور. عندنا 4 فروع في الشرق الأوسط. عندنا شركة في الإمارات، شركة مصرية، شركة في مصر، وشركة في قطر، وشركة في السعودية. احنا الشركة بتاعت مصر اسمها بدر عصفور، لسه في مصنع لسه مفتوح ما بقالناش 6 أشهر. اللي هيعمل انتروداكشن دلوقتي هنتكلم عن الفاير والسموك building, smoke management in buildings. Mr. Na'man, our CBS GM in UAE, he will start this presentation. Inshallah.
مين اللي عايز نعمل؟
طيب. Okay, welcome everyone. My name is Na'man. Good afternoon everyone, thank you for coming. My name is Na'man. I will be presenting interesting topic like Dr. said, it's fire safety and smoke management in the buildings. So just to introduce myself, my name is Na'man. I am the General Manager of CVS and I am Technical Director for the Badr Al in Egypt. I am part of AMCA Board of Directors. I am also Chair of AMCA for the Middle East Region Steering Committee. And I am also part of UL Technical Panel for UL 555S. And I am also part of X-Ray Falcon Chapter. I am co-chair for Government Affairs Committee. Okay, so I think it's better. So just to start my presentation, today we will be trying to go through quickly with the corridor smoke management system. So it's a 20-minute slot, I cannot go very deep. So what we will do, we will just go through the concept and the standards which are linked to this system. So the principal goal for the corridor smoke management system, it is like, if you can see in the sketch as well, you have one vertical riser which is for smoke exhaust, which you can see in the red, and then you have one vertical riser which is for the makeup air. And the goal of corridor smoke management system is that in case of fire, when people are escaping, what you want to do, you want to clear the, the corridor free from smoke. You want to clear the smoke from it's not working. So you can see that for the clearing the smoke from the corridor, so that the people who are escaping the fire, they can use this corridor safely. They can see the exits and they can run away. So this is the goal of the corridor corridor smoke management system. How you achieve it and what are the advantages? You are having a design which we will discuss in the next slide, the little bit concept of the design. So what is the advantage of this corridor smoke management system? First of all, you are controlling the smoke by not fighting against the smoke, but with playing with the natural concept that the smoke is hot. So when you are exhausting the smoke, you are collecting the smoke from the upper part of the ceiling, 1/3 of the ceiling. This is where you are collecting the smoke. And when you are clearing the smoke, you are bringing the makeup air. So makeup air you are bringing near to the bottom of the floor. And this helps the smoke towards the safe exit, which is the top side. So it increases the visibility of for the people who are escaping the building in case of fire, and it also dramatically eases the temperature. For the firefighters when they go inside the building, so the temperatures inside the corridor are also low. So like if you are not removing this, the temperatures can be high also. So it has multiple advantages for the people who are escaping, for the firefighters who will come back. So this is like a typical sketch you can see in the middle. So you have a fan, smoke exhaust fan on the top on the roof, which is like 400 degrees centigrade for 2 hours. And then you have on every floor you have a smoke exhaust damper on a smoke exhaust shaft. So if you observe the smoke exhaust damper, it is located in the upper 1/3 of the corridor. And the criteria is that the bottom of the damper should not be below 1.8 meter. So this is the criteria. You should keep the bottom of the smoke exhaust damper at least 1.8 meter above the floor. Then you have makeup air shaft. So in this specific example, you have 2 makeup air shafts. So for every smoke exhaust shaft, you will have at least 1 makeup air shaft. You can have 2, but you can have 2 makeup air shaft with 1 smoke exhaust shaft, but the vice versa is not possible. You cannot have 2 smoke exhaust shaft with 1 makeup air shaft. This does not exist. If you have 1 makeup air shaft, 1 smoke exhaust shaft, then you will again have a makeup air, then you will again have a smoke exhaust. So what you will do, you will end up with equal number of makeup and exhaust, or higher number of makeup. Smoke exhaust will be always equal or lower than the makeup air. Now, what is the criteria for the makeup air shaft? You can see that you are bringing the makeup air near to the floor, and the criteria for the damper to be is that the top of the damper cannot be more than 1 meter above the floor. So this is the guidelines that when you are designing your damper for the makeup air should be close to the floor. And what is the purpose of this? That when you are bringing the air for the makeup, you are sweeping the smoke, and there is a smoke extraction rate between the makeup air and the exhaust air, and then this makeup air is guiding the smoke towards the smoke exhaust. So this is the concept of a corridor smoke management system. Now there are many different standards which are applicable in this system. Like for example, you have ducts. So ducts follows MEPNA DW144. If it's a fire rated duct, it will be following BS 476 part 24, EN 1366-1-8-9. Then you have dampers. So dampers might be following UL 555 or UL 555S, and maybe MCA standard 500D, and then there are some other things. So I cannot present everything today. So what we have picked. So we have a system. So there are 3 main components in the system. Life safety dampers, which you saw in the shafts. You have some dampers there. There is a ducts, and then there is this fan there. So what we will do, we will understand these 3 products and what are the standards which are applicable for these 3 products. So the first is life safety dampers. So just to understand what type of certification and standards are available for the UL fire safety products. So first, UL 555. So UL 555 is a fire damper for fire dampers. Normally there are many tests which a damper has to go through when it has to be UL classified. But the major performance criteria for a fire damper is like fire ratings. So you have, when it comes to UL 555, you have 1.5 hour or 3 hour. These are the 2 fire ratings for UL 555. Then when this damper is tested in the furnace for a 1.5 hour rated damper, the temperature in the furnace goes up to 978 degrees centigrade, and then it follows with the hose stream test. Hose stream means they will apply the water with some pressure, and they will measure afterwards is there any gaps between the blade and the frame, between the sleeve and the frame, and you know there are so many criteria. So the UL will perform the test, they will check everything, and then they qualify your product to be passed for this test only. There are so many other tests you will see in the future slides. And UL 555S is mainly linked to smoke dampers, or combination fire smoke damper also go through both tests. Because it's a fire damper and a smoke damper, so combination fire smoke damper goes through UL 555 test and UL 555S test. If it's only smoke damper, it only goes through UL 555S test. There are so many tests again, but what is the major performance criteria which is coming out of this test is the leakage. So leakage can be class 1 or class 2, and there are elevated temperature. The leakage is tested at ambient temperature. It is also tested at the elevated temperature. So elevated temperature means they will heat up the air, and then they will do the operation, and then they will check the leakage. So the leakage for elevated temperature, there are two ratings only, 250 degree Fahrenheit or 350 degree Fahrenheit. So this is called elevated temperature leakage test. Now, this is very important point as well, because when you install any certified product, the certified product does not bring the safety itself. What you have to do, you have to install the product as well as per the manufacturer's installation guideline. And the manufacturer can only approve the installation methods which he has tested in the UL for this. So there are standard, like for example, the first one you can see is a two-sided angle installation. So when you install a fire damper or a fire smoke damper or a smoke damper in a barrier, you install the retaining angles on both sides of the wall. So when you have this two-sided angle installation method, you attach the retaining angle only to the sleeve. So when during the fire test, what happens? You allow the expansion of the damper. So this is a less severe fire test for the products. You also have one-sided angle installation method. So in one-sided angle installation method, you can see that the angle is installed only on one side of the fire barrier, and there is no angle on the other side of the fire barrier. So when you have one-sided angle installation method, you have to attach the angle, retaining angle on the sleeve, like in two-sided angle, but you also attach it to the wall. So this, when it is done, the fire test with this method, it is more severe as compared to the two-sided angle installation. Why? Because you take away the expansion possibility of the damper during the fire test. So this is more severe. So any manufacturer who has only tested his damper with two-sided angle installation, they are not allowed to approve the one-sided angle installation method. One-sided angle installation method, it is more severe for the fire test, but it is much more better for the installers because you save half of the time on the installation. You need to install only on one side angle. And sometimes you cannot even install a second side angle because there is no space available on the back side of the wall. So one side angle installation, not every manufacturer can provide you approval for that. They have to test their products. So in corridor smoke management system, like you saw, the makeup air damper, they have a problem there because the damper has to be into the corridor wall. Now you cannot use any of the two-sided angle installation because you don't have space behind the wall. You cannot go behind the wall to install the angle on the other side. You cannot have one-sided angle installation because if you saw in the previous slide, if it is one-sided angle installation, angle has to be on the motor side. So you cannot hang the motor outside the wall as well. So it means the both standard installation methods for this application are not possible. So there is a special installation method. If you can see there in this sketch, you are directly attaching the sleeve to the wall. Like you directly attach the sleeve to the wall. Now this only if a manufacturer has tested his product with this type of installation can approve this installation. because this is even more severe than the one-sided angle installation. Because what you are doing, you are attaching directly the sleeve to the wall or the fire barrier. Now, we have one more problem in this application, because you need the access to the actuator from the front of the damper. Now, when you do this, you have to bring the actuator in the front. You are pushing the blades of the damper outside the wall parameters. You can see there that the damper blades are outside the wall. Now, this is another application in UL. Now, this application is called out-of-wall damper application. Because what UL does, if you apply for this application test, UL will measure the temperature from the edge of the sleeve to the edge of the damper. And for that purpose, you need to install a thermal blanket. Because during the fire test, UL will be measuring the temperature rise on the sleeve from the edge to the edge of the damper frame. So for that purpose, if you can see in the photo as well, you can see the blackish, like the surface. It is a thermal blanket. You have to install the thermal blanket on the sleeve, because this, otherwise you cannot pass this test. So this installation method is the ideal method for the corridor smoke management system, where you are bringing the makeup air directly from the wall of the corridor. So the fire resistance rating is 1.5 hour. If it's a fire smoke damper, you can see there is a thermal responsive device. Normally standard temperature is 165 degree Fahrenheit, but we have approvals for up to 350 degree Fahrenheit, fusible links as well. Leakage is class 1 or class 2, and dynamic rating standard is 2000 FPM at 4-inch water column, and installation vertical, because you are installing in the wall. So when you install any fire damper or a fire smoke damper in the walls, it is called vertical installation. When you install any fire damper or fire smoke damper or a smoke damper in the ceiling, it is called horizontal installation. So in this application, we have a vertical installation. So this is for the damper part. And second product was fire resisting ductwork, because when you are having a smoke management system, you have to use a fire resisting ductwork. So fire resisting ductwork, what is the fire resisting ductwork? So we have multiple types of fire resisting ductwork, type A, type B. Type A means the testing will be done from the fire will be, like in the furnace will come from the outside of the duct. Type B means in the furnace, the fire will be from inside the duct. There are uninsulated ducts, there are insulated ducts, and one of the standard which is popular in this region is BS476 Part 24. In Europe, it is already like obsolete. It is like EN 1366-1, -8 and -9. But in this part of the world, still BS476 is still working. We have stability, insulation, and integrity. So what is being done during the test? They are doing the test. They are checking the stability. Stability means that the ductwork shall not collapse during the entire test duration, which is 120 minutes or 240 minutes. And integrity means during the whole test there will be no cracks or leakages from the joints. And insulation means they will be measuring the temperature. So for thermocouples, the average temperature should not rise more than 140 degrees centigrade. And for any particular thermocouple, the temperature should not rise more than 180 degrees centigrade. So one of the most important criteria, like the fire test. So when the fire test is happening, it is happening with the ISO 834 curve. When ISO 834 curve means when in the furnace, when the time is 120 minutes, the temperature in the furnace is around 1049 degrees centigrade. And when the time is 240 minutes, the temperature is around 1153 degrees centigrade. So there are some, manufacturers, they bring their duct tested at 400 degrees, they call it a fire rated duct. It is not a fire rated duct. Go ahead. Like this is the comparison between what I am saying. So this is the two different curves. The first one is the actual ISO 834 curve, where the temperature is at 120 minutes is around 1049, at 240 minutes is around 1153. And on the right side, when you see the curve, during the whole test, the temperature is maintained at 400 degrees centigrade. So this, any duct which is tested at this method, it is not qualified to be called as a fire rated duct. If you can see one here, 400 is here on this duct. So this duct is tested for the whole time at this temperature. And while actually it should have been tested this. So there are standards in international, like you can see that this is from, reference from the DW144. They are clearly mentioning any duct which is tested or assessed at 400 degrees centigrade, it is not a fire rated duct. You cannot call it a fire rated duct. It has, if it's a fire resisting duct, it has to be tested at ISO 8345. So other now, like BS476 part 24 is one of the standard, and there are 3 more standard which is European. In this region they are still not popular, but in Europe BS476 part 24 has already been replaced by these standards. So they will come, but maybe down the line 10-15 years they will come. So the third part of the system was the fan. So this is like it's Novenco fans, which is like providing the smoke exhaust for buildings, tunnels, car parks. So this fan is tested as per EN 1210 part 3. So what is EN 1210 part 3? The fan is kept outside the furnace, the duct is connected, and then the fan is extracting the hot air, and this is continuously done, and they measure that up to 2 hours if the fan is performing, then your fan is certified. So the fan is not put in the furnace. The fan is put outside the furnace, and it is just extracting the hot air. So this is the purpose of the smoke exhaust fan also. What it is doing, it is just extracting the smoke. So this is the application, and this is the certification for that. So you can have like in like different parts of GCC there is 300 degree for 2 hours also, but now 400 degree for 2 hours is coming in all the region, because already in Saudi is there, already in UAE is there, others will follow. Before it used to be 300 for 2 hours. So this Novenco fan is the most efficient fan, like in the industry. They have reached up to 92% of the efficiency, and it is because it has a very unique. You can see the shape of the impeller. It is like very aerodynamic. You can see the shape of the blades. It's very aerodynamic. You can see even the gap between the blade and the casing. You cannot put even your credit card inside this. It's so small, it's so precision, like in the construction. So based on all these factors, the fan achieves up to 92% efficiency. So in conclusion, just to remember whatever I said, always approve, always install the dampers as per the manufacturer's approved installation instructions. Don't let the dampers installed by anyone by any method, because the damper itself does not bring the safety. If you don't install it right way, it will not bring the right safety. Always install as per the manufacturer instruction. And any fire resisting ductwork which is tested below 1049 degree, it is not considered as a fire resisting ductwork. And this is one of the very important factors, especially in this part of the world, that if you install a UL listed fusible thing on a damper, and then you claim that the damper is a UL classified damper, it's wrong, because the damper itself has to go through a lot of tests. And you have to go on UL website. This is the UL website. You can make your own login. You go there and check. Anyone is claiming, I have a UL classified dampers range. Go on UL website. Check what range they have, and this is only what they have in UL. Like, in short, if you install a damper and a fusible link, it is not UL classified. You see all these tests, this is what I was telling you on the table. If a fire damper has to get UL classified fire damper, it has to go all these tests, fire endurance, hose stream test, operation test, blah blah blah. There are so many tests. The damper has to go all these tests, only then it can be called as a UL classified. Same for motorized product, like just having a damper and installing a UL listed electrical fusible link and a UL listed actuator, and then you claim that my product is a UL classified product. It is not true, because the damper has to go through all these tests to qualify as a UL classified damper. So when anyone is claiming, you have to go on the UN website, you will find out. This is for smoke damper because there is no TRT. So in short, if you go on the link which we have provided, you will find out the name of the company and you will find out what are the damper models they have. So this is like, for example, this is for Badr 4, it's in Egypt, and you can see the file number and they have a lot of products which are UL listed. You will find the list on the UL website. So there are like Badr 4 and CDS, we have also multiple files in Egypt, Qatar, KSA and UAE. So another important aspect to remember that all the stakeholders must collaborate with each other. Like manufacturers not only are responsible, there are regulatory authorities. There should be a relationship between the regulatory authorities, building owners, consultant, contractors, manufacturers and suppliers. It has to be a collaboration if we have to maintain the integrity of the industry. Now, in the end, just quickly presenting ourselves. So we are Badr Naspur. We are the first and the only manufacturer in Egypt who has complete range of UL classified fire dampers, combination fire smoke damper, and smoke damper. So if you go on UL website, you will find out, like the previous screenshot was from us. We are a family-owned business, probably in the region for more than 2 decades, and we have multiple factories in the region. Egypt is one of them, of course. We have a factory in Qatar, we have a factory in UAE, we have a factory in Saudi as well. So we are in the region for more than 2 decades, and we have a big range of certified products, not only fire safety products, like UL products. We have EN standards as well, we have European standard as well. We have also AMCA certified products as well, which is doers, dampers and other products. So this is our range. We have dual classified range, we have fire rated, like CEF4 is our fire rated range. And we also represent Uniflex. The next slide section is our colleague, I will invite him. So they have fire rated insulation, so he will be presenting them. So now I will invite Vignesh. He will present you the fire safety insulation, fire rated insulation, and we can take questions together at the end. Thank you.
Take you through this fire resistance rated reset and air stacks. Okay, so how do you use our fire app system? Okay. So these are the topics which is going to be covered during today's session. So how do you promote awareness? What are the informed decisions? And what are the code prescribed performance requirements? What are the various duct fire test standards? And how do you demonstrate equivalency to ISO 834 as oblique ASTM E11952? And what are the various UL listing categories, and what are the industry evaluation, and what this is not, and why should you use our flexible draft systems over other technologies. So if you see the system which we are talking about, it is Fire App. Okay, Fire App is our brand. Okay, it's a flexible draft system which was a tested system by UL as well as from Intertech. It's a high temperature insulation fiber which can go up to 2300 degree Fahrenheit, and it is made up of alkaline earth silicate wool, which is considered to be a low biopersistent, and it is encapsulated for weather protection, and it is non-combustible, and it's when you wrap on a duct, it gives you a tested system. Next. So why are they used? Okay, because you all know, like now sustainability is a buzzword which is going in every market. Okay. So how do we address to the sustainability requirements is that these wrap systems, it can help you on the life safety as well as protection of property, like business continuity. So in that way, we are ensuring that we are also adding some sort of help to the sustainability requirements. Next slide. So where are they used? Okay, if you talk about any buildings, talk about high-rise commercial buildings, casinos, restaurants, hotels, conventional centers, metros, schools, hospitals. So wherever you see a high-rise building, okay, you have a requirement for this kind of fire-rated duct insulation. So I'll not take much of this. Okay, so fire resistance rating is simple. Like you need to avoid the propagation of fire from one compartment to the other. Okay, so that's what we are just talking about. Okay, how do you call a fire resistance rating as per IBC code? IBC chapter section 703 will talk about the fire resistance rating. Next slide. Okay. So the main intent of this code is to provide a compartmentation. Okay. So which means if there is a fire, okay, inside a room, it should not propagate through the unexposed area. Okay. So it talks about ISO 834 as well as ASTM E1195 standards. Okay. So that ultimately you have to protect. Yeah, next slide. So how do you achieve a fire resistance rating? Okay. So it's like Mr. Nacman was talking about. Okay, the key criteria. Okay, the stability, integrity. Okay, insulation as well as the hose rate. Okay, so this is for a wall assembly. These are the requirements. Okay, the hose stream test is an additional requirement, but as far as fire protection of ducts is concerned, okay, you need to consider these three criteria like stability, integrity, and insulation, which are the key. Okay, so now how do you replicate this wall assembly test requirements to a duct scenario? Okay, so next slide. So on this, okay, so when you talk about all these criteria, which one can be omit or reduce? Okay, you cannot omit anything. Okay, the moment you are not fulfilling any of these criteria, then you cannot claim that as a fire rated product, okay, or fire rated system. Okay, so that's what it talks about. Now, introducing a duct to the same assembly. Okay, it is simple. So when earlier we talked about a single product inside a fire rated duct. Okay, but now if you talk over here, okay, so you can see a fire rated duct which is crossing a fire rated wall. Okay, so it is equally important for a duct to maintain the compartmentation, and also you need to keep the fire out to not transfer, keep the fire in to not transfer, and maintain integrity of the wall and the horizontal assembly, and also you have to ensure that the fire stop and the penetrations are being intact. So as far as ducts are concerned, there are some test standards, okay, which were specifically or purposefully built for these kind of ducts. Okay, in ducts, you know, like there are so many type of ducts like air ventilation ducts, kitchen grease ducts, smoke ducts, okay, and there are many ducts with dampers, okay. But ISO 6944/BS476, okay, because Mr. Nacman clearly told in this region, okay, we either adopt this ISO 6944 or BS476, okay. Both the ducts will talk about these three criteria which I highlighted on a wall assembly, okay. So this is the key, like, okay. So both these ducts clearly says like, okay, a duct, when there is a fire in a duct zone, okay, it should not propagate, there should not be any integrity issue, and even the insulation criteria is also critically more important, because when you have a fire on the unexposed side, the other side, now when you have a thermocouple, it should not exceed 140 degree plus ambient. Next slide. So similarly, as I said earlier, here also we cannot omit any criteria, because the moment any one criteria is being neglected, then you cannot claim that as a fire rated system. So this is just to give you like, okay, how ISO 6944, all three criteria are being equally important. But the only thing is that this ISO 6944 or BS476 is more of a subjective language, and many areas we have seen from our experience that there is a lot of a misleading factor, okay, which is going around the market. So that's why if you go to the next slide, if you see in US, okay, they have gone to the advanced level, okay, which is more of an enhancement to this ISO 6944 and BS, but it's a long way for this region to adapt. But here they talk more about the prescriptive as well as the mandatory language. So that's the different nomenclature which they are trying to introduce in this upgraded versions of the standards. Okay, so this is the one key chapter, okay. So because we have been working with CVS for quite long in all GCC countries, okay. So many areas we have seen, like for kitchen grease duct, they try to say, okay, no, why don't your duct be tested for BS476 or ISO 6944? But if you really see, NFPA is 96 and IMC, International Mechanical Code, clearly states that, okay, if it is a commercial kitchen grease duct, then it has to follow the ASTM E2336 as clearly mentioned in NFPA 96, okay. But we have seen like there is always a misleading factor which is going in the market, like, okay, they say no, my duct is tested for ISO 6944 or BS476, it can be used for a kitchen extract duct. So that's why, because if you talk about IMC or NFP 96, they clearly says, okay, a grease duct serving a type 1 hood, okay, which penetrates the ceiling, wall or any assembly, okay, from the first point to the penetration to the outlet terminal, it has to be completely protected in an enclosure, okay. So our wrap system is going to give that as a dedicated enclosure once you wrap it around, okay, and yeah, okay, so that's what, and so this is how ASTM E2336 is done, okay. So they have to do an internal fire test, okay, 500 Fahrenheit for 4 hours, followed by a 2000 Fahrenheit for 30 minutes, okay, and they will measure the surface temperature requirements, okay. A single maximum thermocouple should not exceed 121 degree, okay. So there are different criteria, you know, which we will measure, okay. And the main thing, okay, because today if you see the building environment, okay, the commercial construction, no, space is a constraint, okay. So, but all these systems, you know, the wraps which I have been talking about, no, it is completely tested for zero clearance to combustible, which means, no, you don't need to provide any sort of clearances. Next. So this is just to show you know how they are tested for a duct A assembly. Next one. This is for a duct B, okay, for a fine engulfment. Yeah. Next. So this is some photographs to give you some idea how it is being done. Next. Yeah. Few more. Okay. So what these standards don't do is that okay, they do not discriminate against any technologies, okay, and they do not cheat the test as fire stop systems do, okay, and they do not allow for partial applications of field application materials where they say, okay, my system can give you partial zero clearance to combustible, okay. So this is something no which, so because it is all a tested system. So next. So this just to say like okay, UL listing, no, because in this part of the world, no, we either follow majority of the industries, no, are following UL listings, okay. So in UL listings, they have special categories. Can you go to the next slide? Yeah. The HNKT talks about the grease duct assemblies. HNLJ talks about the ventilation duct assemblies, and HNLN, okay, will be talk about the uninsulated ventilation duct. Yeah, next. Yeah, next. So this clearly says like okay. What does HNLJ talks about ventilation duct assemblies? Okay, so after this we can share you this presentation for your reference. Yeah. So this is what we talked. Okay, so when you really investigate into all these test standards, no, you have to see like okay, see here if you see a typical test report listing, clearly says for duct A it has 3 hours rating, but for duct B it has a 1 hour rating. Okay, so obviously this plays a major role because many areas, people say no, for duct B also, I can give you a 2 hour rated system because but it is misleading. Okay, so it has to be like 1 hour only maximum it can give. Next. Yeah, this is for the uninsulated ventilation duct. Okay, what UL clearly says, if you have an uninsulated ventilation duct, okay, then you need to provide 18-inch clearance on the periphery of the duct. Yeah, next. So this is what they clearly mention in all their listing categories. Okay, if you see uninsulated ventilation duct assemblies are intended for use in environments where the clearance to combustible materials and combustible assemblies is at least 18 inch. So where do we have space like 18 inch in today's space requirement? Yeah. So included in the listing. So what we have to see like okay, the rating specifies okay, that like whether it is a fire resistance rated system or it's a normal system, okay, and it will also clearly depicts like that size and construction, supports, material specifics, and what do we do like in case of a third party approval, specifically for that size of maximum. Like next, yeah. So this is our typical flexible wrap systems. Okay, if you see we have a single layer duct A with zero clearance to the combustibles for duct A application and 2-layer system for duct B. Next slide. So the key takeaways, okay, so code requires testing to ISO 834 and ASTM E19, and you cannot test the duct to ISO 834 or E119. So that's why there is a need for purpose-built test and duct standards. Okay, and grease ducts, as I said, it has to be completely in compliance to NFPA 96, which talks about only ASTM E2336 test standard. So alternatives must maintain intent of the code, which is nothing but the fire resistance, and can't omit any pass-fail criteria, just like ISO 830, which we clearly said. All three criteria has to be fulfilled, okay? And you cannot do partial installation on clearance to combustibles, okay? And like the other thing, duct fire test standards don't discriminate, okay? So here, temperature rise rating, which is the insulation rating, is the key, okay, for any systems, and they don't discriminate. Yeah. So this is just an evolution, because now every jurisdictions is becoming increasingly aware, okay, and IBC clearly talks about this UL categories, and UL category also regularly changes and providing clarification to all the end users. So this is just shown, like, okay, for New York, okay, you see, they clearly says that the stability, integrity and insulation, okay, is key for any fire resistance rating, okay. So, next. So thank you so much. So okay, so because of the time constraint, now we just want to rush up, okay. But anything, myself and Mr. Nacman is always available, and we are there to have any Q&A session.
any questions؟ في أي أسئلة بخصوص محاضرة؟ طبعا it was a lovely 2 lectures for the duct fire rating, numbers, the installations. So, any questions? Please.
So this question is about the fire rapidity. For these blankets, can we have these blankets? You've mentioned that they are failed installed, but is it possible for a contractor to purchase the duct from any manufacturer? Because in every region, every city and country like Egypt, it's a big country, you can't necessarily ship from many different areas to a particular area. But any project, for example, the ones in Alexandria or Alumni, can they purchase the ductwork from a manufacturer localized in that area and then use the fire wrap elite blankets on it? And if they do that, is there a particular duct construction that you would advise them to follow, or do they just use SPACNA's duct construction?
Actually, if you see all our testings, okay, listings and testings, we have tested for the worst case scenario, the minimum requirements as stated in SPACNA. So you always have the leverage to buy a duct from a duct supplier OEM, and you can buy the installation from us, okay, and you can install it at site, okay, and make it as a fire rated duct. So that is always open. That's why we have tested with the minimum gauge thickness, okay, so that it is always a worst case scenario.
Sorry, I have a follow-up. For the kitchen extract system, there is a different ASTM standard. Can you explain why the ASTM kitchen standard is different from the ISO 6944, and what makes the kitchen so sensitive that you have a different standard for it? What's the actual what are you trying to mitigate there with the kitchen standards?
See, ISO 6944 specifically talks about fire from outside, okay, so, and certain criteria they test from inside. But if you go in detail to ASTM E2336, okay, in a kitchen grease ducts, okay, you have all the oil sediments which will be depositing on the periphery of the ducts, okay, on the internal lining, okay. So when you have a real fire which happens inside, the fire scenario is not cellulosic, okay, it is hydrocarbon, okay, because you have all the oil derivatives which is getting burned. So that is the reason, if you see, I told when I talked about ASTM E2336, I told it has to be tested for an internal fire test, okay, 500 degree Fahrenheit for 4 hours, followed by 2000 degree Fahrenheit for 30 minutes, okay. That is where you have the spark flame, okay. And similarly, it has to be tested for an outside fire test also. So in both the scenarios, this is going to be the right test standard for specifically for kitchen grease duct, okay. This ISO 6944 is not going to address this criteria. Thank you. So, anyone else have any?
Any other questions? Otherwise, we are okay. And we have a booth, by the way, if you want to have any questions, want to see more the products, we have a booth in hall 4, J9, you can visit.
So I have one question for you. Mother's Food makes these UL dampers in Egypt, or are they imported at all?
No, they make in Egypt, like you saw in this one of the slides, I showed you the Mother's Food UL file number. So if you want to see whoever is the manufacturer in Egypt, you go into UL website, you select the Egypt country name, you will find all the manufacturers who have UL classified products range, and you can see their range also in that specific UL website. So Mother's Food makes all their products locally in Egypt. So you can buy from Mother's Food.
Can we specify them in our products as Egyptian-made products?
Yeah, why not? Because see, if it's locally products available, providing you all the certified ratings, so it's better to have a local manufacturer because you have all the challenges coming from outside imported products. So it's I think better to specify UL classified dampers, and you see what manufacturers are locally. So always prefer local manufacturer, but make sure that they don't just install a UL listed actuator on their product and they say this is a UL damper. No. You have to go on UL website. You have to verify what is their UL certified range. Thank you.
Thank you. I'd like to thank for this informative presentations and for CDS company. It was a really pleasure and honor for HVAC-R chapter to host you for this conference. We'd like to give you a simple certificate award from our HVAC-R chapter. Thank you, Mr. Nعمان. Also thank Mr. Finch for his lovely presentation for the installation. Thank you. Thank you, Mr.
Thanks. That's right.
Thank you.